Question 8. This question is about Bronsted-Lowry acids. Give the meaning of the term Bronsted-Lowry acid. It's a proton donor or an H+ donor. What is meant by the term strong when describing an acid? It means when you put it into water it completely dissociates into H+ ions. Completely dissociates in water to give H+ ions. You can use the word ionizes if you prefer rather than dissociates. At 298K, 25 cm cubed of a strong monoprotic acid contains 1.45 times 10 to the minus 3 moles of hydrogen ions. Calculate a value for pH. So if you've got pH, you need H+ concentration, because pH is minus log to the base 10 of H+ concentration. I've been given a volume, I've been given a number of moles, so I can work out concentration of H+ ions. So volume is 25 cm cubed, divided by 1000 to get into decimeter cubed. Concentration is moles divided by volume. Concentration is 0.00145. I've been given that in the question. Divided by the volume, 0.058. So I've got the concentration of H+. pH is minus log to the base 10 of concentration of H+. So that comes out as pH 1.24, which is reasonable for a strong monoprotic acid. Monoprotic just means that 1 mole of the acid makes 1 mole of H+, something like hydrochloric acid or nitric acid, unlike something like sulfuric acid where 1 mole of the acid makes 2 moles of the H+, a diprotic acid. Question 8.4. Calculate the pH of the solution formed after the addition of 35 cm cubed of 0.015 mole decimeter cubed of sodium hydroxide to the original 25 cm cubed of the monoprotic acid. So my first thing is I've been given a volume and a concentration of sodium hydroxide. It wants me to get work out the number of moles. So volume is 35 cm cubed divided by 1000 to get into decimeter cubed, 0.035. Concentration is 0.15. Concentration is moles divided by volume, 0.15. The concentration is moles divided by 0.035. Multiply the two numbers together, and so the number of moles of sodium hydroxide is 0.0525. The sodium hydroxide, which is an alkali or a base, will react with the acid. So let's have a look how many moles of acid I had in my original question. In my original question I had 1.45 times 10 to the minus 3 moles of hydrogen ions, which have come from the acid. So the moles of the acid from the previous question is 0.00145. The number of moles of sodium hydroxide is larger, so when these two neutralize each other and react with each other, 1 mole of sodium hydroxide will react with 1 mole of the monoprotic acid, then sodium hydroxide is going to be excess because 0.0525 is a larger number than 0.00145. Let's work out how much is in excess by subtracting the two. I've got 0.0038 moles of sodium hydroxide left over in excess. So I've been given the ionic product of water, Kw. Now you need to remember that Kw is H+ concentration multiplied by OH- concentration, and I'm trying to work out pH. So if I'm working out pH, I need H+. I've got Kw, I now need OH-. If I can work out OH- concentration, having got Kw, which is 1 times 10 to the minus 14, I can work out H+, and I can work out my pH. So that's the way I'm going. I've got the number of moles of sodium hydroxide in excess. I've got my new volume. I've added 35 cm cubed of sodium hydroxide to 25 cm cubed of the acid. Add those two together. I've got 60 cm cubed of solution. Divide by 1000, 0.06 decimeter cubed. So I've got the number of moles of the sodium hydroxide, 0.0038. I've got the new volume, which is 0.6. Divide the two to work out the number concentration, because concentration is moles divided by volume. I've now got my concentration of OH- ions, 0.0633. So 1 times 10 to the minus 14, which is Kw, equals the H+ concentration multiplied by OH- concentration, 0.0633. H+ concentration is 1 times 10 to the minus 14 divided by 0.0633, which is 1.58 times 10 to the minus 13. So I've now got my hydrogen ion concentration. pH is minus log to the base 10 of that, 12.8, which seems reasonable for a strong alkali or a strong base. A buffer solution is made by 1.5 grams of sodium hydroxide, so immediately I know that I can work out the number of moles of that by using the MR. added to 1 decimeter cubed of 0.1 mole decimeter cubed of a weak acid. I've got a volume and I've got a concentration. I can work out the number of moles of acid. So let's do that first of all. So for the acid concentration, 0.15 is the number of moles divided by volume. I've got the volume in decimeter cubed, which is 1, so multiply the two together and the moles of the acid is 0.15. The sodium hydroxide, the MR, sodium is a 23, and O is a 16, and an H is a 1, so that equals 40. Moles is mass divided by MR. Moles is the mass, which is 1.50 grams, divided by 40, which is the MR, 0.0375. So I know the number of moles of sodium hydroxide, I know the number of moles of acid. Which is the larger? The acid, so the acid's in excess. So let's work out how much by. 0.15 take away 0.0375 is 0.1125 moles of acid is in excess. Now I know a weak acid, HA dissociates to make H plus and A minus, and for a weak acid my equilibrium constant, my acid dissociation constant, Ka, are the concentrations of these on the right hand side divided by the concentration on the left hand side. But for buffers you can't use H plus squared. You're not allowed to use H plus squared. You've got to do something different. I cancel a concentration on the top and a concentration on the bottom. So if you cancel a concentration on the top and a concentration on the bottom, H plus concentration stays the same. A minus concentration just becomes A minus, or the number of moles of A minus. HA loses the concentration and becomes moles of HA. So you cancel a concentration of A minus and just leave it as instead of concentration A minus, it becomes moles of A minus. Concentration of HA becomes moles of HA. Now then, I can do the next bit. So my Ka, which is 1.79 times 10 to the minus 5, or 0.000179, equals the concentration of H plus multiplied by the moles of A minus divided by the moles of HA. Well, I've just worked out the moles of HA, which is 0.1125, and my moles of A minus are equal to the number of moles of sodium hydroxide. That's just a trick you've got to learn. So my moles of sodium hydroxide give me my moles of A minus. So that's 0.038 from my original question, or 0.0375, 0.038 if you round it up. So now my H plus concentration is 0.000179 multiplied by H plus concentration. I've multiplied these two out to give 0.338. H plus concentration, these two numbers divided, 0.005295. pH is minus log to the base 10 of that. pH is 4.27.